Okay, I'm going to talk about a special scenario where you have when you have two vectors of same magnitude and the angle between the two vectors being theta, and as shown in this diagram. So what we're trying to figure out is the sum of the two vectors and the difference. So the sum of the two vectors would have a magnitude of 2f cosine half of the angle, and its direction would be along the bisector of the angle, so exactly in the middle. So along this line, this is the line of action of the resultant, and also the direction of it, and this is going to be 2f cos half of the angle. That's the sum. Okay, that's the sum we're talking about. Now also we can talk about the difference of the two vectors, whatever that means. If you subtract the two vectors and its magnitude would be equal to 2f sine half of the angle, and its direction would be equal to it will be always perpendicular to the bisector. That's it. So it would be in a direction which is perpendicular to the bisector. This time I'm only talking about the direction, not the line of action, and we have discussed about the difference between those. So the difference between the two vectors would be in a direction perpendicular to the bisector. You can even take it right around here. Anyways, it has to be perpendicular to the bisector. Now let's try to get these answers using the knowledge we have. I'll first use the algebraic method that we have already developed a formula. As you can remember, we have discussed this at the school or the class. For a situation where you have two vectors of magnitude p and q at an angle theta, the angle between the two vectors being theta, then through the parallelogram law of vector addition, we developed a formula for the resultant. Okay, the magnitude of the resultant was p squared plus q squared plus 2pq cosine theta square root. And if we consider the angle the resultant makes with the force P, and that angle was the tan inverse q sine theta over P plus q cos theta. This was what we discussed about adding two vectors. If you remember, I told you to think of this as this block of knowledge, right? This block of knowledge, think of it as, okay, I know how to add any two vectors. I know formula to add any two vectors. Right, so we will first before we go into the actual calculation, we can also think about subtracting vectors. In this case, if I want to say subtract q from p, let me draw another diagram. So vector p is this way, vector q was this way, and the angle was theta. I want to subtract q from p. So what I'm going to do is I'm going to reverse q and make it minus q. Now the angle between the two vectors become 180 minus theta. Now constructing vector p minus vector q, let's call it vector d for the difference, okay? And in this case, the magnitude of p can be magnitude of d, or the difference, can be taken by constructing the parallelogram here, okay? And that magnitude would be equal to this vector, okay, vector d. And I can still use the formula because subtracting p and q is same as adding p and minus q together. So treating them as any two vectors, since I know how to add any two vectors, by doing p plus minus q, I can get to p minus q. So how do I add p and minus q? I have the magnitude of p as p, magnitude of p is p, magnitude of minus q is q, and the angle between them, right, angle between vector p and vector minus q is 180 minus theta. Since we know this, I can plug it in the formula. Now this time the r becomes d. It's going to be square root magnitude of p, magnitude of minus q is again q, plus 2 times p times q cosine of 180 minus theta, which will become, because the cosine of 180 minus theta, this part, is equal to minus cos theta. So finally, you will get the difference can also be taken from a formula. You simply have to change this plus to a minus. Okay? And if you do the same thing to the tan value, it was this. So I'll just write tan alpha equals q sine theta p cos theta. But this time, to get the tan alpha, okay, I'll mark the alpha with the p, just like we did in the earlier one. So tan alpha is going to be q sine 180 minus theta. Remember, q is the magnitude of that one of the vectors, which is minus q, vector minus q for us, but its magnitude is also q. And p plus q cosine 180 minus theta. Upon simplification, so this is going to be q sine 180 minus theta is just sine theta, and cos 180 minus theta is going to be minus cos theta. So this is p minus q cos theta. And you could say, let's call this angle beta, okay, not alpha. Since we used the alpha for the previous one, I have changed the angle to beta. Now beta is equal to tan inverse q sine theta p minus q cos theta. Now what we're doing is unnecessary. I just this is the thing that you need to know, and which you can easily remember, and the idea behind it. So subtracting vectors can also be done with the formula if we simply substitute the angle between two vectors as 180 minus theta. And to subtract vector q from vector p, you will have to reverse the vector q, but reversing the vector q doesn't change its magnitude. So in the formula, p and q would remain as it is. Only thing that would change is the angle to 180 minus theta. Cos 180 minus theta is minus cos theta. Sin 180 minus theta is sin theta. Okay, this is it. Now, why did we go here? We wanted to figure out how to do this using the equations. Okay, so let's try it. Let's first try the sum, then we will try the difference. Okay, so if we use the formulas properly, we should get these answers and the directions properly. So first we will try the sum. I'm going to do it fast. I'm not going to talk too much. Okay, let's add these two vectors together. This one being f, this one being f, the angle between them being theta, and the resultant I want to figure out. So I plug it in the formula. Let me write it as r squared so I can later put the square root sign. So it's going to be f squared plus 2ff cos theta, which is going to be 2f squared plus 2f squared cos theta. And if I take the 2f squared out, I get 1 plus cos theta. Now I am in trouble. If you're doing physics, if you haven't had any trigonometry understanding in mathematics, people are doing maths, must have done this. So you're stuck here. So this is a problem with using formulas in physics. Sometimes in order to go forward, you need some extra knowledge if you're just using the formula. What this suggests is, this is not too mathematical. This is a simple thing, but the bio students won't be able to go forward from here. Now, how you understand it is not by sinking into the idea, okay, I'm doing bio, I won't be able to understand. No, what you have to understand is, okay, this is not the appropriate way to do this. There must be other easy ways to do this problem. Okay, so keep that in mind. Now, in case you are interested, I'll move forward by simplifying this. The 1 plus cos theta can actually be written as twice cos squared half of the angle. Okay, which in turn becomes 4f squared cos squared theta over 2. This is our r squared. So r, taking the square root of both sides, and we just need the value of it. So 2f cos theta over 2. It seems very easy. Now, this is the part where you need, like I mentioned, you need some mathematics, which comes from the cos 2 theta formula. Okay. 2 cos squared theta minus 1. And using this, we can figure out this. So anytime you have something like 1 plus cosine of something, you can write it as twice cosine squared half of that angle. Similarly, if you have something like 1 minus cosine of something, you can write it as twice sine squared half of that angle. So that's the extra knowledge for math students. You can grab that and move forward. Now let's quickly calculate the tan alpha thingy. So this is my alpha in this situation. I'm going to put the alpha with this. It doesn't matter because this is a very symmetric one, and we're pretty sure it is through the bisector, so you don't have to run it through the formulas, because if the two vectors are identical in magnitude, the resultant shouldn't bias to one side. If the two vectors are exactly identical, why would the resultant be biased? No, it shouldn't be biased to this f or that f. It should be exactly in the middle. So if you think like that, we already know it's theta over 2. But the whole idea of doing this is, I'm trying to run it through the equations. So if you run it through the equation, tan alpha was q sine theta over p plus q cos theta. So f sine theta over f plus f cos theta. You see, again we run into a problem, because this gives us sine theta over 1 plus cos theta. In physics, there's no way for us to solve this, but those who are interested, especially the math students, the sine theta, I can write it as 2 sine half of the angle, cosine half of the angle. 1 plus cos theta, like we did earlier, it's 2 cos squared half of the angle. Now, upon simplification, 1 cos theta over 2 cancels, the 2 cancels, you are ended up with tan theta over 2. So tan alpha is tan theta over 2, alpha is theta over 2. Now this suggests the resultant is through the bisector. Like I mentioned earlier, it's a simple thing to figure it out looking at the symmetry of the 2 forces. Now, I don't want to go into the difference formula. If you do that, and you would find similar statement, you'll have to simplify in similar ways, and you will end up getting along the bisector and perpendicular bisector idea, and the values being 2f cos theta over 2 and 2f sin theta over 2. Now, let's do this in a different way now. Okay. Now I'm going to use a geometric method. Okay. Since I know these 2 vectors are same and the angle vectors are the same, means the magnitudes are the same, angle between them is theta. Now I'm going to construct the parallelogram and try to do this geometrically. So if I construct the parallelogram, and this is the sum, okay, I'll call it by R. And if you remember, we discussed this in the class, the difference can be taken from the other diagonal, the magnitude of the difference. Why I'm not getting it? Okay, like this. And this will represent the difference. Whatever the way you want to do it, like if you're subtracting from this f, if you're subtracting this vector, then your difference would be in this way. And if you're doing it the other way, it's the other way. Because the order matters in the difference. But here we are only interested in the magnitude. And if someone tells you from which vector you're subtracting which vector, then you can say the actual direction. Now, if you look at the diagonals and the parallelogram we have, you must understand this parallelogram is a rhombus. Okay? Rhombus has special properties. One property being diagonals being perpendicular to each other, which straight away gives us the idea that the sum and the difference are perpendicular to each other. And a rhombus, in a rhombus, this angle is bisected. Right? Not in a general parallelogram. If you have a general parallelogram, the diagonals does not bisect the angle. See? You can clearly see this angle and that angle are clearly different. In a rhombus and a square, okay, that means when all the sides of the parallelogram are same, when all the sides are same, right, that's a special property of a square and the rhombus. See, the angles bisect and the diagonals are perpendicular to each other too. In a general parallelogram, diagonals are not always perpendicular to each other. You can say it, say. Right. So the angle bisects. Now we know this is the sum. So the direction is pretty clear. It's in the along the bisector. Now the difference is perpendicular to the bisector. All these ideas are now clear. Now what we need is the value of it. In any parallelogram, if you recall, the diagonals bisect. That means this distance is equal to this distance. Okay? So the diagonal bisects. The whole 4 parts are not equal to each other, not necessarily equal to each other, but generally in a parallelogram, they bisect. So the rhombus is a special case of a parallelogram. So we know the R value, the sum, okay, R is equal to twice this much, okay, because this is same as that. So twice one of this. Now this one, this triangle, okay, is a right angle triangle if you observe. That means you can easily write this red highlighted side to be f cos theta over 2. If you look carefully, we have a triangle like this where you have 90 degrees here, f here, theta over 2 here. And if I'm looking for this side, I can write the cosine of the angle theta over 2 as x over f, which in turn gives me x is equal to f cos theta over 2. Or you can also think of it as resolving f into this direction. Either way, we can get that length. So see, the r is twice f cos theta over 2. Similarly thinking, now the d is actually this plus this. And since the diagonal bisects, this is twice this red piece. So thinking similarly, so I can write the magnitude of d is twice this red piece. This red piece being this length, which I can use to write sine of theta over 2, which is y over f, which in turn gives me y equals to f sine theta over 2. So d is simply twice f sine theta over 2. Now go back and try to think about the different ways that we use to get to the answers. So here the magnitudes I found using geometry and the special properties of the rhombus. And I thought about the properties of a general parallelogram and special properties of a rhombus, which allowed me to calculate the values for the sum and the difference. Also geometrically see which way the sum is pointed and which way the difference is pointed. In this case, we only thought about the difference being perpendicular to the sum, but the sum is exactly along the bisector pointing out of this point. Now if someone wants the difference idea, the concrete idea, let's call this vector f1 and this one is coming from vector f2. If someone is asking you to figure out f1 vector minus f2 vector, vector d, say vector d is this, then we can specifically say the direction of it, because this is my vector f1, this is my vector f2. So if I want f1 minus f2, if you remember, this is taken by adding minus f2 vector to f1, vector f1. So minus f2 vector is reversing this, okay, reversing this. I can simply reverse it and draw it on the same. Then this is our start. I'll use the triangle law of vector addition. Okay, starting from here, I come like this, then I move like that. Okay, this is my end point. So from start to the end, I have f1 plus minus f2, or f1 minus f2. You see, if it was f2 vector minus f1 vector, it would be the other way around. So either way, it is along this other diagonal. It's along this other diagonal. So, and we know it is perpendicular to the sum, whatever the direction it has. So this video took a little more time, But what I want you to understand is the techniques, different things that we can do. We can make it a little bit more mathematical, rigorous, and we can make it geometric. Most of the times that's how we do things. So we need a little bit of geometry, a little bit of simplification skills, and most of the things we have learned in our O levels. Now, there's another part I want you to understand. So if you think in terms of layers, this is one layer you can have, rather than like focusing on how to understand this. The first layer being knowing this block of knowledge. For a situation where I have two identical two vectors with same magnitude, their sum is equal to 2f cos theta over 2. Their sum is equal to 2f cos theta over 2, and it's along the bisector. Then you say its difference is equal to 2f sin theta over 2, and it's perpendicular to the bisector. That knowledge, take it as the first layer. So try to remember it, then try to see it in questions. When a question is given with two identical magnitude vectors, then suddenly this should occur to you, maybe I use this knowledge. Then you can expand your knowledge by thinking about what we did. Okay, we used our knowledge about the equations, and we altered those equations to handle a different scenario, and there were little mathematics involved, which is not needed for a bio student or a math student in physics, but I just mentioned it because the math students can use it for their maths parts. And then we had a geometric approach. Okay, geometric approach to the problem. So in that geometric approach, we dealt with rhombus, okay, and thought about its properties and general properties of parallelogram. We used a little bit of 90-degree triangles and sines and cosines. So doing this, you could like grab other pieces of knowledge, and we also discussed like the sum being in a particular direction. Like if you say this vector minus that vector, or that vector minus this vector, the direction would be reversed. And we also use the triangle law to get the actual direction of the vector. So there are a lot of ideas associated with it, so you can think about them. It's not a necessity, but that's a secondary thing. Like I mentioned, the first thing and the primary thing is knowing this block of knowledge, okay, what you see in the screen. And then you can expand your knowledge from here to everything that we discussed. So that's it for this video, and we will meet with another video next time.